כותרו. really like this order, I would say swap the A and the C. But yeah, other people seem to like this. For example, this guy also uses A as coefficient of x squared. So let's keep it like that here for now. Yeah, under what circumstances can we definitely conclude that the smallest root in absolute value is there? I mean, if R1 plus R2 is not vanishing, so if the absolute value of R1 and R2 are more or less the same and they have the opposite sign, then R1 and R2 would be vanishing, or maybe, yeah, then this whole term would be vanishing. It would not be of the order of the absolute value of R1 and R2. Meaning that no, we can't say anything about that. I just have to compare these two. I mean, if R0 is small, then this is neglectable compared to that. And this in absolute value is much smaller than that. Is that sufficient? No, there is no not much less than. There is a not less than. Tja, doesn't want to copy it. Framework. I'm just in my browser talking to ChatGPT. I'm talking to myself, but So A equals, I said that this equals R1 plus R2, more or less. So A equals this, and I say that it is more or less that, therefore A is more or less that. Now what the hell? I can't copy from here for some reason. And then B is more or less something, and C is more or less something. So R0 is very small, so we just pick this one, this part. And for C, yeah, we have to keep everything, I think. So now I have here the absolute value of R1 plus R2 times R1 times R2. That is then A times B. Well, I was using more or less. Said the absolute value of R2 is less than R1 is less than R2. But you can't say anything about it when we make it negative. Unless, of course, I'll just define the sign here, I guess. So if R1 is positive, so there would be say larger than or equivalent to. What? Nothing, really? What the hell? Greater than, that's larger than. Okay, let's this is of course a factor of 100 over the AI's capabilities, but why not have some reflection? I think I got at least one good answer this month. Yes, there is a way to detect when the absolute value of R0 is much less than R1, which is less than or equal to the absolute value of R2, even when R1 and R2 have opposite signs, and their sum, R1 plus R2, has an absolute value that is small compared to both R1 and R2. So it does understand my question, because this is basically the summary of that. The key lies in observing the relationship between the coefficients b and c of the cubic polynomial, x to the power 3 plus ax squared plus bx plus c. Specifically, we can consider the ratio c divided by b from the expressions of b and c. B is this and c is that. When absolute value of r much less than that, the terms are 0, R1, and already we keep it negligible, already said that. Then we can approximate B, it's just repeating me. Similarly, since C equals minus R, blah, 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 and we can write, yep. Thank you for repeating me. Well, I had the R0 on the other side, but okay. This leads to, okay, and then whatever leads to. Therefore, the magnitude of c divided by b gives us an approximation of R0 when the absolute value of c is much less than the absolute value of b. Wait a minute. Now this is bullshit. This is only true if R0 is much less. The absolute value of R0 is much less than the absolute value of R1 and much less than the absolute value of R2. Then that is true, because it used that, it used this to derive that, and then eventually this. When the absolute value of c is much less than the absolute value of b, it indicates that the absolute value of R0 is much less than the value of R1 and R2, regardless of the signs of R1 and R2. Yes, I think that's what I said as well. What a failure. So completely not answering my question. Okay, well, it's not exactly the same. I'm talking about A times B. Absolute value of C and B are compared. I disagree with this. That's not okay. That's not much less than. Well, that was not my question. I can make it a question. Actually, maybe not. So if C is not much smaller than B in absolute value, is it then possible that R0 is much smaller than R1? Maybe we should write a little brute force program to just test it. So in the case that C is not much less than B, let's say much less is 100. So if it's much less, then it is less than 100th of this, but if the 100 times that is larger than the absolute value B, then it is not much less, I think. And then I still want to know all the cases where R in fact R0, absolute value R0 is much less than the absolute value of R1. What did I do all wrong? Well, first of all much less, right? So even if I multiply this with 100, say, it still must be what, less than that. And that's probably going to be an edge case-ish. I mean, if this is not 100 but 99, we might get in that neighborhood anyway. Yep, and the absolute value of R0 should actually be less than R1 and less than R2. That means that probably should do it the other way around. So I want our absolute value of R1 to be less than or equal R2. So it must be minus the standard absolute value of R2 plus absolute value of R2. And R0 minus the standard absolute value of R1. Yep. Absolute value is CMOF. So definitely less than, much less than those, more than a factor of 100. But apparently not this. Let's print that too. Not this, I mean, right? So we have to print C. B and C. No, let's just print the absolute value. Yeah, it did stand or fall with the ratio between these two, right? C divided by B. The absolute value of C must be much less than B. I'm just gonna print C divided by B, right? No, that looks like a definite case, or they're absolutely not unequal. Well, R0 is still very much smaller. What? It says even correct? Is this even correct? Yeah, it doesn't really look correct. What is the 960? Yeah. highlight this thing. Yeah, we're just wasting time with AI. Right? So my idea was to compare. What was my idea? To compare the absolute value of C with A times B. Where A is minus the sum of these things. A is minus the sum of the roots. And now we're going to look for a case where that is not true, but still R is much less than R1. Let's see what that gives. Really. Okay, now of course I have to print here something else as well. We're now talking about C divided by A times B. Infinite even. Yeah, I think this is a good example. But as you can see that R1 and R2 are of opposite sign and almost equal. Preferably, they differ exactly the size of R0. So if you add all of them, then you just get 0. Which then you divide by 0. So that's then the absolute value C is definitely not going to be much less than AB. Let's try to find one where, for example, this one is also nice. So that's just one. No, it's not actually. This is 9. But still, not even less than 1 here. I think I want, yeah, and it gets better and better. 4. Yeah, until you reach infinity again. Let's print the largest value of this thing, but let's not print infinity, because then I already understand where that came from. I think it's pretty clear. These two are just, opposite sign and more or less the same value. That's the only conclusion that you can draw. Let's see what ChatGPT said. You're correct. Yeah, the standard start of any reply. Criterion C is much less than B is not reliable for detecting if R0 is much less than R1 if R0 is not negligible in absolute terms compared to B. For example, clearly shows that even when that ratio can be greater than 1, this indicates we must have a robust method to detect the revised approach detect. We can use C squared divided by B cubed. That is a different approach. Not using A. It might actually work. It's a reasoning backwards. It's using the fact that it's using approximations, assuming that the absolute value of R0 is much less than the absolute value of R1. While that's not necessarily the case. I just want to detect when that is the case. Yeah, this is also not true. Yeah. Okay, well, we can try it. Because my approach fails on R1 and R2 being each other's additive inverse, more or less. The more or less being R0 itself. Especially then. You could maybe test that separately, but let's try this one. So that would be I guess c squared and b cubed compared. So we want this to be small. So then this becomes c cubed. And then here we do, sorry, x squared, and then here the b cubed thing. And we want this to be a factor of 100th. So before taking the cube, before taking the root, that's going to be 10,000. Printing the wrong thing again. It's printing a lot to begin with as well. Let's see. R0 is 3, R1 is 694, and R2 is minus 939. You need to verify the ratio actually reflects, and hence whether the detection formula works in this scenario. Calculate coefficients. A is minus that, B is that, C is that, correct. A is, calculate, 242. I guess it's not making a mistake there. Minus 364 minus 9 something. Yeah, okay. And B is that. Okay. Which is big because of the 600 and 900 thing. C is multiplication between all of them. Okay. Yeah, why would it do that? That's still a whole completely different value than I had. I mean, I got 15. So am I doing something wrong here? Mm. What? Again something else. No, this is less than 100th. So this program is wrong. It's definitely not 15. Hi, AG. The integer can contain 1000 to the power 3, can it not? Maybe not. Yeah. Totally can contain that. How the hell is this printing 15 when the actual value is less than 3000 or around 3000? This is the square root of the absolute value. Yeah, of c times c, which is an int, it fits. Cast it to a double so that we can divide it. So this is c squared divided by b cubed. Maybe this goes wrong, but even then. Yeah, that doesn't fit. Yeah, let's just use larger numbers here. Might as well use long here. Just long all the way. And it was printing this. Let's just test that. Okay, so now we do not trigger this. So I want to switch back to int to understand this thing. Okay, it prints 15. Why does it print 15 though? I'm still not getting that. That's a 242. B should be that. One is 652,401. Yep. C is 2 million-ish. Yep. And then 8. Yep. And then this goes wrong because this is overflowing. And then we print here this, and I don't think this is overflowing, so I don't get it. C times C. And it is, of course this is overflowing. C is huge. Oh, I'm doing C squared. I'm not. I was thinking about one of the R values. Yeah, totally overflowing. Yeah. You can't do this squared in an integer. Might as well cast the C to a double and then multiply the thing. Work with double from the beginning. Okay, that was pretty stupid. And this also won't work then. B might be very large, but already be a million. That should probably just convert the whole thing to, I mean, the A, B, and C to double already. Make this double. And I still keep long for those then, I suppose. Yeah, now it should work. No, this is actually working then, because it's just 1/100 is small enough. I mean, it's larger than 100, but hardly so. To say we are looking for the largest such value. That seems to work. What was it that I had? C A times B. Okay. So this is not working. Infinite, yeah. Totally not working. And the other one is working. Well, then why is it saying that I was right because I was arguing? But then it calculated it and it came to the conclusion. No, I was not arguing. I was just asking it to check it. And then it figured out that it didn't work. What? It should totally work. Yeah, I never get something this big. The largest thing I get is 0.010. Never this. So I guess it's just not calculating things correctly. Oh, what? What? 100 times 3, 300 is less than 694. Yes, totally. So we should get here. Whatever the ratio is, it's not going to be 0. Don't tell me it's going to be 0. No, this is not 0. Oh, wait a minute. It's going to be not a number because I have this bracket wrong. Yeah, this is bullshit, of course. No, it's the position is 6. Whatever you mean with position, right? Because it's just printing 6 decimals behind the dot, regardless. Yeah. Just copy this. 38. Okay, that's a little bit too much. Pretty happy with 15 here. No, it is not bad. I said I got this. It ends on 7216. And then it recalculates it. And it gets something that ends on 7201, which is the exact value. What the fuck? I was just starting to praise it. Van, hey, it corrects me and it uses the correct value. And then it says, for practical purposes, as in I don't want to smack the human, I want to get a thumbs up, we'll use the value that you gave. just a cut. Well, what? It's literally only adds 15, which has no practical application whatsoever. Unbelievable. Right. So maybe hello, Clement. So maybe we should look at this value, and then if it is much smaller than 1, use a different algorithm. Okay, I have a particular cubic where everything went wrong. I can paste it on Discord. Let me see where I have it. What's this one? This is not my code. This is code that some professional coder uses for a big company. So they sell it to their clients. He gave me the code. And when I ran into this polynomial, I tested his own code. So this is up here. To see what that gave. This is the Cardano thing that uses a cosine and stuff like that. Well, there's a cosine in it. And that gives the roots 106, which is more or less a root. A very big negative number, which is hardly a root in my eyes. And again 106, but a little bit larger than that one, which is absolutely no root whatsoever. So yes, 106, very large negative number, and 106. Now what is the actual root? The actual root is this. 0.25000, a quarter. Really? I want my money back. Oh wait, I didn't pay for this code. So yeah. So I told him on Discord, and he said, well, it doesn't surprise me because of this number here, which this is the coefficient of the third power. So that basically we just have a quadratic here. It's just a quadratic. Hell, even this is small. It's just a linear function, really. It's basically a linear function. if I draw this, I can, let me show you. This is, do I even have viewers? We have viewers, okay. So they came from the program, oh boy, which one was it? Yeah, this one. Bleep. Okay, let's show you where that came from. So my problem is that if I want to approximate this cubic exclamation mark with a Bezier curve, then we only need a single Bezier curve because it's a cubic. But what happens is that it started to divide this in tiny little pieces because it thought it had to divide it even further and further and further because it couldn't find a match. And what I did was that as soon as it cannot find a match, and I make it stop and then draw the piece that it has a problem with, which is this piece. So you see there's just a big zoom in between minus 15.94 and minus 15.78. So that is over here. Well, you can't see the bottom. Can I make this smaller? No. Minus 15.94 is about here. So we are here. This piece here. And then a little piece of that. Yeah, and vertically we are at 5 something. 5 point something. So yeah. So this little piece here gives the following problem. The cubic at that point looks like a straight line, yes? And I want to know what the distance is from this point here to the cubic. Well, it's on top of it, so the distance is very small, and therefore it should be approved. But then I call my code, which calculates the distance between this point and the cubic, and that returns plus infinity. What happens? Well, this straight line is really a cubic Bezier, which means that it is a curved parametric function, which curves like something like this. It's round. So it might look straight here, but if you go to plus infinity, it's going to curve back and then, you know, again comes here, very, 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 very high. And what we do, I'm drawing a vertical line here and then calculate all the intersections of that vertical line with the Bezier curve, which gives me 3 intersections. This intersection and one at plus infinity and maybe another one also very far away. And we calculated by solving the roots of a cubic, which I have been working on for 2 or 3 weeks. And that code thought to be smart and just calculate the root that is far away from 0. So, and then once we have that, turn the cubic into a quadratic and simply solve that. Well, so what it does, it draws this vertical line and says, hey, there is a solution very, very far up there. So let's calculate that one first. And then once it has that, it divides the cubic by x minus that value. And that gives a quadratic, which it then solves. But by then we have lost all accuracy. And I think that the value it finds for this point, so t runs from 0 to 1 here. So this is about at a quarter. So half, 1, 3/4, 1/4, 0. But instead of finding a quarter, it finds minus 0.16, so somewhere here. But it's probably not bad if you come from plus infinity, or several trillions. But yeah, the code says, wait a minute, I am looking for an intersection point between 0 and 1. So if it only intersects it at t equals minus 0.16, then it doesn't intersect it, not between 0 and 1. So there is no intersection point, aka doesn't find this intersection point. And that's the problem. Now, the cubic that it solves has root at 0.25. That is the cubic that I just showed here. But as you can see, it's just basically a linear function. Kill this thing. What was I doing? Where was I working at before I did this? Can't remember it anymore. Oh, here. Yeah. Yeah, so this cubic here is basically a linear function. You just saw it. Yeah, and we're only interested in x or t, whatever, between 0 and 1. And that's a straight line there. And then there are small coefficients for the x squared and even smaller for the x to the power 3, which then in the end make it have also a root at very large numbers, but we are not really interested in that. However, it is going to calculate that first. So not practical cubic. So now I'm going to test with these values. If we can detect what I have been detecting now, namely that there is a root that is much smaller than the other roots. Where's my foo? There is no foo here. Probably to go here. So foo here, there's a foo here. Good. So I want to work with that. Right, so I don't have my roots now. We just have these values, and to be honest, this is for a monic. I would say it really doesn't matter that you make it a monic, but I'm gonna do okay, let's call these things slightly different. But this is the real coefficient. I'm gonna call it this is the square one here, so just call it C2. It's a coefficient of t squared. And C1 and C0. And this is C3. And then, yeah, we don't have the roots, but we can fill in A is C2 divided by C3. To make it monic again. Monic meaning that C3 is 1. So we're going to divide all coefficients by C3. So the linear term divided by C3. And the constant term divided by C3. And then C3 itself is just 1, so we don't have that here. And then this won't compile because you don't have R0 and R1 anymore, but I'm just going to go into there anyway and print everything. And then we can't print this either. Let's put it on a different line. Quote. Let's see out. So yeah, very small, very small. So if we use this, then I would even say less than 100th is already a good reason to switch to a different algorithm. This one would totally switch to a different algorithm. Totally. Because it's way, way, way smaller than 1. And then, of course, my new algorithm is going to be excellent in finding roots that are very small compared to the other roots. The only question is, how does that algorithm work? How can we make that work? I'm going to start with maybe detecting it. So we have math. So let's turn on the music that I'm listening to. It's rain. I'm listening to rain sound. No, it's not rain actually. It's a combination of a clothes dryer and ocean sounds, as far as I can tell. Yeah, I don't know. Maybe I'm bothering people with it. I'll turn it off. So you can play your own stuff. Moth. Now I could still start the same way I do now. Which then finds the large root first. No. There's another problem, namely. So what I'm doing here is we scale and shift to cubic. And that turns out to be not a very good idea, actually. If the root that then you find is going to be 0 after shifting it back. So that would be yet another algorithm, really. So I should not do that if the root is very small. The root is very small compared to the required shift. Wonder if we can detect that in advance. Plus, we're talking here about I was gonna say we're talking about one of the roots being much less than the other roots. What happens if I just have one root? Can I still talk about it then? Like that? Maybe we're talking about the absolute value of the complex roots. I don't know, really. I don't know what's being detected in that case. way. So if it has a local extreme, then maybe we have multiple roots. But even that isn't very certain. Does it depend on this? No. I'm not even sure where to detect this thing. I think it works pretty much, except when after shifting back it becomes almost zero. Then it doesn't work. And then we have another problem at the end. Here, if the cubic has a local extreme, then we find the other roots. That then doesn't work. I mean, it could be that here now we find a root that is much smaller than the root that we already found. So it could have it could put the detection here and then apply another algorithm again to find one of the other remaining roots. I'm just wondering if it wouldn't be smarter to detect this earlier. Maybe the other way around. The other way around it would work better. Doing a long division here. What if we do long division with the root that is small instead of the root that is large? Maybe that's way more stable. How does the long division work anyway? So in our case we had something that was almost a straight line, so this is vertically zero. This one is very small as well. And this is the slope and this is some constant. Now we're doing R2. I mean, now we're going to a quadratic. And now it's R2 almost zero, so it's still a straight line. And then 1 becomes that quadratic plus almost zero, so that is still almost zero. It's like this becomes a constant. No, I don't like to calculate the root of a constant. Yeah. This was something 10 to the power minus 12. And this was also pretty small. So if r is small, then it works much better, right? I mean, then it's just a shift. Looks like it will be more precise. Yeah. So in the end, if you want to find the zero of this thing, then you still have to divide that one by this one. It's not good that this drops out. Oh, wait a minute. In the end, we have to find the large roots then. So yeah, maybe long division with a small root will work. Have to try it out, I guess. Okay, let's see. Let's see if ChatGPT has something intelligent to say. Think. Let me think. What I wanted to ask is... I think that, I mean, a cubic has always one real root, and the other two roots, which it always has, of course, it's a cubic, but the other two could be complex. They are, yeah, complex conjugates of each other. So the absolute value of R1 and R2 are per definition the same. as soon as they are complex. Which means that then if one root is much smaller than the other, that has to be the real root. Which is, well, very interesting. Or both of these, of course. Yeah, it's possible that R0 is the large one, and both R1 and R2 are equal but much smaller than R0. That is also possible. I would wonder if we would detect that as well. Okay, let's say when a cubic has one real root and a pair of complex conjugate roots, that is when it does not have three real roots, the situation changes slightly, but the detection method remains applicable with minor adjustments. Understanding the root and coefficients, consider a monocubic polynomial with real coefficients. Suppose the roots are now we defined R0 as the smallest root, and now it also calls it a real root. It's kind of half the story. But okay. Its coefficients A, B, and C are real. The complex roots must come in conjugate pairs. Yep. Calculating the coefficients. The relationships between the roots and the coefficients are the sum of the roots is that. Since R1 plus R2 is 2 alpha. We can fill that in here. Some of the products of the roots 2 at the time. Yep, that would be B. B is R0 times. Is that, yes, here, that is that. Product of all three roots. Is that applying the detection method? Assumption R0 is much smaller than the rest. Under this assumption, the term 2 alpha R0 in the expression for B becomes negligible compared to alpha squared plus beta squared. Oh? Yeah. No. Wait a minute. No. Oh, that's already, unless alpha is very small. Yeah, but then this gets even smaller. It's a nonsensical remark. So this is much smaller than the absolute value of this, which means that alpha times R0 is less than the square of this, or the length of these things. You would say that is true, yeah, because even alpha is dominant in the length, and then R0 is just much less than that, so alpha times R0 is much less than alpha squared. Or beta is dominant, for example, in which case alpha is very small, and then if you multiply this with alpha, it gets even smaller. So the unless is nonsense, but the beginning is correct. I mean, this is just becomes negligible. Therefore, we approximate B with, what was B defined? Again, B here. Okay. And that became this. Yeah, so if R0 is absolute value of R0 is much smaller than the absolute value of the other roots, then this can be neglected. And it becomes more or less the length of the complex roots, B. Well, the square of that. Yeah. Let's C and B. C is more or less. It's not more or less, it's exact. It's the other way around. This is exact and this is more or less. Minus R0 times B. So R0 is more or less minus C divided by B, still. The detection ratio. B is more or less that. Big jump here. Oh yeah. Okay, so this is C squared divided by B squared. And then the square root of that. No, but no, this is C divided by B. And so under the square root is C squared divided by B squared. Yeah, okay, I agree with the formula. Okay, but this was only half this, sorry. Because now you assumed both, assumed that R0 is both the smallest root, absolute value, as well as the real one. It is also possible that I think yes, R2 is the real one, has the real root, and absolute value of R0 equals the absolute value of R1 is much less than R2. Do your thing. That's interesting. So now R2 is the negative of the coefficient of the x squared. The squared term. In this case. Sum of the products of the roots 2 at a time. That was B. And this is that. R0 plus 1 is 2 alpha still. Compute. The remaining stuff. So B is B. B is the absolute value of R squared plus 2 alpha R2. Yeah. That seems nonsense. Something is going wrong here. Yeah, this is that's definitely not correct here. I think it should be the square root of the absolute value of R2. It's kind of, yeah. Yeah, that is true. So if beta is, the absolute value of beta is much larger than the absolute value of alpha. Alpha can be arbitrarily small. So you could theoretically be dividing by 0 here. So that would blow this thing up arbitrarily. It's going in circles. We already had that. So it's the same formula as before. No. Yeah, that's yeah. Let's inspect this thing visually 100 times a second, or how many do I need? Hmm. Hmm. I used to have 4 possibilities here, and then I deleted 3 of them. This comment is still talking about 4. Yeah, it's time to go to bed. We're gonna play some chess. That should be advantageous for me. That he moved the bishop twice. Should not have put this pawn here. I want to go there with my knight. Damn it. Completely messed up, man. So I have this 3 times, and yeah, got it 1, 2, 3 times as well, plus 4 actually. So I can just push it, even if I take here then. If he pushes and I take, he takes back with the queen, then it's 3 against 2. So he's gonna take back with the pawn. Let's stop him from casting short, I guess. Castle short, I think. I can also do this. Yes, he castled short. That's what I wanted to see. Suppose I'm going to castle short as well, actually. No, especially after this move. That's not good. That is not good. Which rook? I think this rook actually. Yeah, well, yeah, okay. I have to admit. Running out of time, damn it. Double rooks here. I can put more pressure on this by playing my bishop here. It's probably a good move. Probably a good move. Let's first develop my rook. Threaten to take it. That's not even stopping me. Dude, what the fuck? I'm so winning now. Totally winning. Except I have 2.5 minutes less, but for the rest, nothing can go wrong anymore. Resign, as it were. Yeah, he can resign. This is totally finished, isn't it? I mean, I don't know why I didn't even move the rook. I could have taken the rook as well. Should I take the rook? Should I just take all the pawns? I could take pawns. I'd take pawns instead of rooks. It's always funny when they think that I might run out of time because I have no time left. No, I'm not running out of time. No, you just play fast. Faster than in the beginning. Not the best move. No. And look who is running out of time. Not me. Actually, maybe I am now, because tough decisions. Gonna chase this bishop away, but the bit of my knight is really annoying. 13 seconds. Oh, he's probably taking my knight. Just take back. And then defend my king. In the end, I want to be pushy here. Not sure if we can do that. What the fuck? Okay. Yeah. When I went away from the first row here, I was already feeling that it was not good. Then I went to the last row, I should have gone back to time pressure. Went to the last row, I should have gone back. Simple as that. I did feel time pressure. Well, actually, I have 30 seconds. And this guy is almost out of time. Where is the time pressure? No time pressure. But why I did think that it was necessary? Yeah, it's just stupid. I should have gone back. I guess you move it up, and then you don't want to go back for some reason. I was confused with having my king here. The king is here, and then this is made because of the bishop. Therefore, I took the bishop. But the king is not here. The king is here. Why did he even walk there? This move is stupid as well. And my pawn is even defended. I don't know what I saw. I don't know what I was doing. Huh? New opponent? Shit, I wanted to analyze this. Yeah. Oh shit. Stupidity. All over again. He did not want my pawn for some reason. Huh? And resign. Yeah. What shall we say about it? It did cost a piece. You can't go here, can't keep defending the bishop, so you just take the bishop. Let's play one more. Take the center. Defend the center. So he wants to push this pawn and attack my center. So maybe I can do this. He does it anyway. Let's take towards the center. And now develop. Yeah, if I take with the queen, you can just develop with tempo. That's not it. I'm gonna go here to the knight. It threatens to exchange here and take my pawn. Can't move it, can't unpin it, I lose it anyway. Can't pin his own knight. Do I get a double pawn here? Castles, there's not. I want to play this one, so I think I want to. I want to castle. It's kind of suckage that I have to go here instead of there. It attacks my pawn again. So we now castle, he takes here and then he takes here. Oh, wait a minute, actually he takes my knight. And my pawn. I can go back though. No, he can still take it. No, he can't take my knight. He could take here first, and then I take back with the queen. So the real problem is the pawn. We could go back anyway, I think. Whatever castle, or then he takes a check. Could play this, he just takes there, 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 there. I don't like that at all. Also not possible. I can pin this knight. I think that I like that best. So he can't take my knight because I just give check here and then I win the queen. This seems to cost a piece, but yeah, if now I push this pawn, he does take it, of course. Okay, but I could push it anyway. Man, I have to castle. That is the problem. I really have to castle. Well, actually, if I push it, I can still give check here. Haha. So he can still not take it. So it costs a piece. I push, he takes my knight, I give check. Best move, I guess, this pawn. Ahaha, yeah. Definitely a good move. No, I'm gonna castle. Because if I don't castle now, but then I lose my pawn. Fuck. Yeah, well, I castle anyway. I don't want to think much any longer anymore. It's 1 minute. Oh, he takes a check. Oh, I'm so dead. Oh, I should have thought this was the same as before. Castling wasn't possible because he took a check. Now I lost a piece. I should have resigned. That cost me equality. If we give check here, but go here, I give double check, and then it's finished. Yeah? So I have to take it. Then he probably exchanges that. No, it does not. Oh, that would be stupid. Yeah, then he would have lost a knight. Now I can attack here. It's development, kind of think. Plus I don't want to have the rook here, or there, for that matter. But if I do that, he's going to develop the bishop, for example, here. Everything is bad. Yeah, he's threatening. No, he's not threatening to do this. I'm going to just do this. See what happens. Probably not very good. Probably not very good. Oh, if the rook went here now, then the bishop is defending it, so I can't even take it. Okay, I guess I thought that. I haven't seen that one. Okay, that's slightly annoying there, yeah. But this threatens mate, let's put it that way. Does threaten mate. Yeah, I don't have a check here or anywhere. Yeah, I'm running out of time, so let's just play this, see what happens. It's going to take my bishop, otherwise he's dead. The other moves just made into, yeah. What are you thinking about, man? I'm having the feeling that I do not have anything here. Let's develop this piece because I need it. And I'm dead. Yeah. Well, to be expected. Let's go to bed. Good night.